March 15, 1943. The North Atlantic, 400 miles southwest of Iceland. The sea is iron-gray beneath low clouds, and U-boat commander Kapitänleutnant Hans-Joachim Schwantke stands in the conning tower of U-43, scanning the horizon through Zeiss binoculars. His boat has been submerged for nearly 16 hours, stalking a convoy that passed overhead in the darkness. Now, with daylight fading and battery power critical, he orders the boat to periscope depth. The diesels need to run, the batteries need charging. It's a calculated risk, but one every U-boat commander must take. What Schwantke cannot know is that 12 miles away, a Royal Air Force Coastal Command Liberator has already marked his position. The aircraft commander, Flight Lieutenant John Greswell, throttles back and begins a shallow descent. In the bomb aimer's position, Sergeant Thomas Walsh lies prone, watching the grey water rushing beneath. There are no depth charges in the bay today. Instead, something else hangs in the racks. Something the Kriegsmarine has never encountered before. U-43's deck breaks the surface at 1847 hours. Schwantke cracks the hatch, and salt spray hits his face. The lookouts scramble up behind him, and for perhaps 30 seconds, everything seems normal. Then one of them shouts, pointing northeast. The Liberator is already committed to its attack run, barely 200 feet above the waves. Walsh toggles the release. A single cylindrical object, roughly the size of a beer keg, tumbles away from the aircraft's belly. It doesn't fall like a bomb. It descends more slowly, and from its tail streams a small parachute. The object hits the water approximately 80 yards from U-43's port beam. For 3 seconds, nothing happens. Then the Atlantic erupts. This is the story of the Mark 24 mine, codenamed Fido by the Americans who manufactured it, but known to the RAF as something else entirely. The first acoustic homing torpedo ever deployed in combat. And it represents one of the most closely guarded secrets of the Battle of the Atlantic, a weapon so revolutionary that U-boat crews who survived its attack were prohibited from discussing what had happened to them, lest the Allies realized their advantage was known. By early 1943, the Battle of the Atlantic had reached its crisis point. German U-boats were sinking Allied merchant vessels faster than replacement tonnage could be built. In the first 3 months of 1943 alone, U-boats destroyed 627,000 tons of Allied shipping, an average of nearly 8 ships every single day. Convoy losses were mounting. The statistics were brutal and simple. If the current rate continued, Britain would be starved into submission before American industrial might could turn the tide. The problem wasn't finding U-boats. Improved radar, direction-finding equipment, and Enigma decrypts had given the Allies unprecedented intelligence on U-boat positions. Coastal Command aircraft were locating submarines with increasing frequency. The problem was destroying them. A U-boat on the surface, caught by surprise, might be sunk by depth charges before it could dive. But an alerted U-boat commander had perhaps 45 seconds from the moment of aircraft detection to get his vessel beneath the waves. Once submerged, the U-boat became extraordinarily difficult to destroy. Depth charges had to fall within roughly 20 feet of the pressure hull to guarantee a kill. An aircraft traveling at 180 miles per hour, dropping weapons from 200 feet, attacking a target that was actively maneuvering underwater, faced odds that were frankly appalling. The mathematics were stark. Analysis of Coastal Command attacks showed that even when a U-boat's position was precisely known, the probability of a kill with conventional depth charges rarely exceeded 12%. Most attacks resulted in nothing more than rattled nerves for the U-boat crew and wasted ordnance for the aircraft. Meanwhile, every failed attack taught the Germans more about Allied tactics. U-boat commanders learned to dive deeper, to execute sharp turns immediately upon submerging, to rig for silent running. Some boats survived a dozen attacks or more. The Allies were winning the intelligence war but losing the killing war, and that was the only war that mattered. What was needed wasn't a bigger depth charge or a better bomb sight. What was needed was a weapon that could hunt, a weapon that didn't rely on the bomb aimer's skill or the pilot's timing, a weapon that could follow a diving submarine into the depths, pursue it through evasive maneuvers, and destroy it with the cold, mechanical certainty of a predator that never tired and never gave up. In 1942, such a weapon existed only in theory. By March 1943, it existed in the bomb bays of RAF Coastal Command aircraft, and German U-boat commanders were about to discover what it meant to be the prey. The weapon began at the Harvard Underwater Sound Laboratory in Cambridge, Massachusetts, where a team of American scientists and engineers had been working since 1941 on the problem of acoustic detection. The theoretical foundation was sound. A submerged submarine running its electric motors generated a distinctive acoustic signature. Propellers churned water. Hull plates vibrated. Even the quietest boat produced noise that propagated through the ocean far more efficiently than through air. The challenge was building a device small enough to be carried by an aircraft, sensitive enough to detect these sounds, and sophisticated enough to guide itself toward the source. The design team, working under intense secrecy at General Electric's facilities in Schenectady, New York, created what they designated the Mark 24. The weapon was, in essence, a small torpedo with a brain. It measured 94 inches in length and 19 inches in diameter. Fully loaded, it weighed 680 pounds, light enough for a single crewman to manhandle into position, heavy enough to carry a 92-pound Torpex warhead that could crack a pressure hull like an eggshell. But the revolutionary element wasn't the explosive, it was the electronics. Inside the nose cone sat an acoustic receiver connected to a mechanical computer of almost absurd complexity for 1943. 4 hydrophones, arranged in a cross pattern, listened for propeller noise in the frequency range between 300 and 1,000 hertz, precisely the range dominated by U-boat electric motors. When the hydrophones detected sound, they fed this information to a relay system that controlled the torpedo's rudder. If the sound was stronger on the left hydrophones, the rudder swung left. If stronger on the right, it turned right. The system updated continuously, creating a feedback loop that drove the weapon toward the loudest source of noise in the water. The Germans called their submarines Unterseeboote, underwater boats. The Mark 24 turned them into underwater targets. The weapon was powered by a contra-rotating electric motor driving twin propellers. This arrangement nearly eliminated the torque that would otherwise send the torpedo into a spiral. Maximum speed was approximately 12 knots. Slower than a surfaced U-boat, but faster than any submarine could manage while submerged on electric power. Endurance was roughly 15 minutes, giving the weapon an effective range of 3,000 yards from the point of water entry. A pressure-activated switch armed the warhead only after the Mark 24 had descended below 50 feet, ensuring it wouldn't detonate if it struck the surface or a friendly vessel. Manufacturing began in January 1943 at General Electric and Western Electric plants across the United States. The acoustic mechanisms required precision machining that pushed American industrial capabilities to their limits. Each unit took approximately 40 hours of skilled labor to assemble, and quality control rejected nearly 30% of completed weapons for various defects. By March, production had reached roughly 100 units per month. By May, that figure had doubled. Total production would eventually exceed 4,000 units, though exact numbers remained classified decades after the war. The weapons were shipped to Britain in crates marked as mines, a deliberate deception that gave the Mark 24 its official designation and helped maintain operational security. The first operational deployment occurred on May 12, 1943, when a Catalina flying boat from RAF Squadron 210 attacked U-456 southwest of Iceland. The aircraft dropped a single Mark 24 from an altitude of 100 feet. The weapon entered the water, activated its motor, and began its spiral search pattern. 0456 had crash-dived 30 seconds earlier and was descending through 60 feet when the Torpedo acquired her acoustic signature. The U-boat's commander, Kapitän Lieutenant Max Martin Teichert, ordered full rudder and emergency speed, but the electric motors that powered his evasive maneuvers only made his boat a clearer target. The Mark 24 struck U-456 amidships at 13:34 hours. The explosion killed 12 crewmen instantly and ruptured the pressure hull. The boat sank in less than 2 minutes. 33 men went down with her. There were no survivors to report what had happened. If you're finding this interesting, a quick subscribe helps more than you know. Over the following months, Coastal Command aircraft deployed the Mark 24 with increasing frequency. U-338 was destroyed off the Spanish coast on the 20th of September, 1943. U-964 was sunk in the North Atlantic on 16th October. U-842 went down southwest of the Azores on 6th November. In each case, the pattern was identical: aircraft detection, U-boat crash dive, Mark 24 deployment, underwater explosion, oil slick. By the end of 1943, the weapon had been responsible for at least 22 confirmed U-boat kills, though the actual number was likely higher. Many attacks occurred in areas where no Allied surface vessels could confirm the results, and the Admiralty, erring on the side of caution, classified such incidents as probables rather than kills. The psychological impact on U-boat crews was devastating. The fundamental equation of submarine warfare had been inverted. For 2 centuries, the advantage of submergence had belonged to the vessel that could hide beneath the waves. Now, diving made a U-boat more vulnerable, not less. The very act of escape, starting the electric motors, opening the vents, driving the boat down, created the acoustic signature that drew the weapon toward them like a magnet draws iron filings. Some commanders, recognizing this, chose to remain surfaced and fight the attacking aircraft with anti-aircraft guns, accepting the risk of depth charges rather than the certainty of the acoustic torpedo. This too proved fatal more often than not, but at least it was a death men could see coming. German naval intelligence was aware that something had changed. U-boat commanders who survived attacks reported explosions that occurred well after the attacking aircraft had departed, explosions that seemed to follow the submarine rather than falling in a predictable pattern. In June 1943, the Kriegsmarine issued a classified directive warning commanders about possible acoustic weapons and recommending that boats maintain absolute silence for at least 10 minutes after any air attack. This was almost impossible to implement. A crash-diving U-boat could not simply turn off its motors. But the directive's existence confirmed that German intelligence knew they faced a new threat, even if they didn't understand its precise nature. The Germans had, in fact, been working on their own acoustic torpedoes. The T-5 Zaunkönig, Wren, entered service in September 1943 and was designed to home on the propeller noise of escort vessels. But the T-5 was a conventional submarine-launched torpedo, fired from submerged boats against surface targets. It represented the same fundamental thinking that had dominated torpedo design since the 1890s. The Mark 24 was something else entirely, a weapon that hunted submarines in their own element, fired from aircraft that could range across the entire Atlantic in a single sortie. The conceptual leap was enormous. British scientists at the Admiralty Research Laboratory had been pursuing similar research, but their program lagged behind the Americans by at least 18 months. When the Mark 24 became available through Lend-Lease, Coastal Command seized upon it immediately. The RAF initially designated it the Mark 24 mine to maintain the fiction that it was a conventional weapon, but aircrew quickly developed their own terminology. Some called it Wandering Annie for its search pattern. Others used Fido, the American code name, after the loyal dog that always found its master. Whatever they called it, they recognized its value. Here, finally, was a weapon that gave them a fighting chance. American-built Liberators and Catalinas carried the Mark 24 operationally, but the weapon was never deployed in significant numbers by Bomber Command or other RAF branches. This was partly due to supply limitations. The Americans retained the majority of production for their own Pacific operations against Japanese submarines, but also reflected operational doctrine. Coastal Command understood that the Mark 24 was most effective when used by aircraft specifically trained in anti-submarine warfare, operating in coordination with convoy escort groups and ultra-intelligence. Simply scattering the weapons across the fleet would waste them. Direct comparisons with German equivalents are difficult because the Germans never developed an air-dropped acoustic homing torpedo. Their focus remained on submarine-launched weapons throughout the war. The T-5 Zaunkönig achieved some success against convoy escorts, sinking several destroyers and corvettes, but Allied countermeasures, notably the Foxer noise-making device towed behind ships, reduced its effectiveness considerably. The T-5 was also plagued by premature detonations and guidance failures. German records suggest that fewer than 2% of T-5 launches resulted in confirmed kills, compared to the Mark 24's estimated 20% success rate. The broader impact of the Mark 24 extended beyond the 22 to 37 U-boats it definitively destroyed. The weapon forced a fundamental shift in German submarine tactics. By late 1943, U-boat commanders were under orders to avoid prolonged submersion in areas with known air cover. This meant surfacing more frequently to recharge batteries, which in turn made them more vulnerable to conventional air attack and shipborne radar. The operational tempo of U-boat patrols declined. Some commanders became overly cautious, aborting attacks on convoys they might previously have pressed home. Admiral Karl Dönitz, commander of the U-boat fleet, later wrote that the introduction of acoustic weapons created an atmosphere of profound uncertainty among his commanders and contributed to the sharp decline in U-boat effectiveness after May 1943. The weapon's existence remained classified until well after the war. Even today, relatively few of the specific attack reports have been declassified, and debate continues among naval historians about the precise number of kills attributable to the Mark 24. What is certain is that the weapon represented a turning point in anti-submarine warfare. For the first time, the advantage of technology decisively favored the hunter rather than the hunted. No examples of the Mark 24 survive in public museums. Most were expended during the war, and the remainder were apparently destroyed or lost in the post-war drawdown. However, the principles pioneered by the weapon live on in every modern anti-submarine torpedo, from the Mark 46 to the Stingray. The acoustic homing torpedo is now standard equipment, its revolutionary nature long since absorbed into the everyday reality of naval warfare. March 15, 1943. U-43 in the North Atlantic, the cylindrical object hits the water and descends. 3 seconds of silence. Then the eruption. Schwanke screams orders, but the words are lost in the roar of the klaxon and the rush of men scrambling below. The hatch slams shut. The vents open. The boat tilts forward and slides beneath the grey water, electric motors driving her down towards safety. Or what used to be safety, because 80 yards astern, something else is descending. Something that listens. Something that turns. Something that follows the electric whine of the motors with mechanical patience, closing the distance at 12 knots, depth gauge spinning past 50 feet, warhead armed, target acquired. U-43 never surfaces again. 46 men die in the explosion, and across the Atlantic, in a dozen other U-boats running submerged beneath cold water, commanders who know nothing of acoustic torpedoes make the same calculation Schwanke made. Dive deep, run silent, escape into the darkness. They cannot know that the darkness no longer protects them. They cannot know that the rules have changed. They cannot know that the weapon hunting them doesn't use eyes. It listens. And in the deep Atlantic silence, a U-boat running on electric motors sounds like thunder.